Okay, so we're going to look at the graph that we discussed in class about the lung capacity, lung volume. So this is essentially what they use as one of the diagnostic tools when you have patients with respiratory issues or things like that, like asthma, COPD, cystic fibrosis, anything that would be respiratory related, when they're looking specifically at how much air can you take in, how much air can you exhale, what does a normal kind of breathing look like in terms of how much air you're bringing in, et cetera. So typically, I would say the graph would look more kind of like this. So I'm going to expand it out a little bit with the colored portion over here. So I'm going to first go through and label it, and then we're going to discuss it. So with the labels, okay, we've got two things over here I want to look at. So this part here is going to be what's called tidal volume inspiration. Okay, so tidal volume. So by definition, tidal volume is going to be the amount of air that's moved in a normal breath. Okay, now I'm going to divide it into inspiration and expiration, breathing in and breathing out. So the blue going up on this in this chart, in this graph, is going to be breathing in. Going down, or the green part, is going to be breathing out. Once again, I've expanded it just a little bit for the sake of coloring it. So we're looking at a normal breath. Okay, so from here to there is going to be about 500 milliliters. Now, this is an adult patient, probably male, so because you have a higher lung capacity in most male patients. And then as you look at females or children, you start to see a little bit different values. But right here with the blue and the green, we're looking specifically at while you're just kind of sitting around, breathing in and breathing out, not thinking about it, just doing it. Then as we move throughout the chart, as we start from here, okay, so at the bottom of the green, we're going to take this normal breath in. That's what we're going up to. And then we'll consider this part that I'm circling right here as our start point for breathing in really deep. Okay, so if you were to measure it on this chart, measure up the same way we just did. We measure up to the top of the purple. Okay, that's going to be what we're going to call inspiratory reserve volume. So that is inspiratory reserve volume. That is, after you take a normal breath in, how much air can you take in after that? That's what they're measuring here. Okay, so inspiratory reserve volume. How much air can you take in after a normal breath in? Okay. Now, as we continue through the chart, okay, you've got essentially a normal breath here. Then we're going to get over here to where the red begins. So here is our start point, right here. For once you breathe out, a normal breath out, you're going to forcefully exhale. How much air can you blow out? Okay, so in this case, we're going to be measuring this distance. So I'm going to kind of keep it consistent across the board. So it's about 1,250 milliliters. Okay, 1,250 milliliters. So that's approximately on average how much you would be able to breathe out, how much air you'd be able to breathe out. And that is going to be what we're going to call expiratory reserve volume. How much air can you breathe out after a normal expiration? Okay. Now, at the bottom over here, this is important. So it's residual volume. So what this is going to be how much air is left in your lungs after you breathe out as much as you can. So there's going to be a certain amount of air that exists in your lungs all the time, okay, that you cannot use even if you wanted to. So The reason for that, okay, is because we still want gas exchange to happen, because that's important that we can still have gas exchange. Because like if you hold your breath and start to move, or hold your breath and think about something, all these bodily processes still need to occur. The second part is going to be the potential for collapse. Okay, if you took all the air out, like completely all the air out, your respiratory system would kind of collapse on itself. The existing air within the system is keeping it maintained. So keeping those alveoli open, keeping the trachea intact, keeping the bronchioles inflated so we can move air. Okay, so you need this residual volume for those purposes. Okay. Now, I'm going to go a little bit further and add a couple equations. Okay, so we've got inspiratory capacity. Okay, inspiratory capacity. So these are equations that they use to calculate certain values based on this chart. Okay, so inspiratory capacity is going to be tidal volume inspiration. Okay, so that's this value plus inspiratory capacity. Inspiratory reserve volume. So if you were to chart it on the graph, you could kind of start down here on this line and be a measurement from here, not just to here, but all the way up. Okay, so this right here. So essentially, I'll mark it off like this. Okay, this is going to be the inspiratory capacity. If you were to mark it off like this, from the peak of the purple all the way down to the flat line down here at the bottom. Okay. That's going to be inspiratory capacity. Now, you've got another equation that's going to be expiratory capacity, so very similar to the first one, expiratory capacity. So expiratory capacity is going to be, after you breathe in normally, how much air can you blow out? So you take a normal breath in, so I'm going to chart it with this kind of bluish color. You take a normal breath in, and then we pause right here. Now what we're measuring here is expiratory capacity. So that is from here down to the bottom of the red. Okay. This is going to be expiratory capacity. The next one is going to be functional residual capacity. So that's going to be after a normal breath out. Okay, so right here, if we start here, we're taking our normal breath out, going down, and then this now is going to be our start point. So we're measuring from here down to the bottom, how much air is left in our lungs. That is functional residual capacity. So you're adding ERV plus RV. Next equation is going to be vital capacity. So you're adding the tidal volume, plus you're adding the inspiratory reserve volume, plus the expiratory reserve volume. So to look at it kind of big picture, you're going from the peak of the purple down all the way to the bottom of the expiratory reserve volume, the red. Okay, this is going to be what we call vital capacity. This is how much air can you use. So we're measuring the purple going, how much air can you take in? The red is how much air can you blow out? Then the last equation is going to be total lung capacity. So this is all the air in your lungs, including the residual volume. So that would be from the peak of the purple all the way down to the bottom of the residual volume. So the very most you can take in, what is that number? Okay, so in this case, it's 6,100, because you're adding tidal volume, expiratory reserve, inspiratory reserve, and residual volume to get the total lung capacity.